Right, in this video we're going to learn about graphs of linear equations, and it's basically the graph of the form y equals mx plus c. M is the gradient and c is the y-intercept. And to find the gradient, here's the formula here. Notice we have to have 2 points because we've got one y-coordinate and another y-coordinate here. And we'll subtract them, the 2 y-coordinates, and subtract the 2 x-coordinates. Now it doesn't matter which coordinate you call x2, y2, and which one you call x1, y1. You'd still get the same answer. So, now let's look at a few problems. I want to plot this graph here. I'm not going to plot, I'm just going to plug numbers in and see what I get. From x equals so these are all y value, x values here, and these are all y values. I'm just going to figure out what there should be. So that's 2 times minus 3, minus 1, that's minus 7. Now I've got 2 times minus 2, yeah? Because I'm putting in these x values, so x is equal to minus 3, and when I put that I get minus 7. So then if I do minus 2, I get minus 5. Minus 1, I get minus 3. Now I get a minus 1. I'm just calculating these really quick because it wastes time, and we know how to do this really. We just put the number in and we'll calculate it. And then if we put 1 in, we get 2 times 2. 2 times 1, that's 2, minus 1, that's 1. And I get 4 here, minus 1, that's 3. And I get 6 minus 1, that's 5. So there's what answers there, there's what x coordinates, and that's basically what we get. And then we can put these points on the graph and we can join them up and plot them. And because we're doing linear equations, these are always a straight line, like this one we're going to be working on next. Now, basically I've got an equation drawn here, and I want to figure out what the equation of this line is. Now, we can see here that the y-intercept's 3 because that's where it crosses the y-axis, so I get y equals mx plus 3. Then the next problem is to find out what m is. So this coordinate's 0, 3, because notice when on the y-axis x is always 0. And this coordinate down here is minus 6, 0, because when we're on the x-axis the y-coordinate's always 0. So I'm going to use this formula now. I'm going to let this one be me x2, y2. So my y coordinate's minus 6 here. And then my other y coordinate is a 0. And then on the bottom one, I've got a 0 here. Minus 3. And then when we figure it out, we get minus 6 divided by minus 3, and that would be 2. And just to show you it would work just as well the other way, I'll just reverse these round. I've got a 0 here, minus 6. I've got a 3 minus 0. Yeah, and I get minus 6 over. So I'm taking away a minus 6, that's a plus 6. I'm taking away minus 6, that's a plus 6. So there's no minus there. And then that's the 3 on the bottom. So then that's 6 divided by 3, and we still get 2. So it works just as well both ways, this formula. So the equation then of this line is y equals 2x plus 3. And then I've even put that as my next problem. That's just coincidence that I didn't figure this problem out before. I just don't know how that's happened. We're going to check if the point 5, 2 lies on this line. So we're x coordinates 5. And notice that we get y equals 13. So the point is actually 5, 13. So no, it doesn't lie on the line. There's no way that lies on the line. That's how we check that. We'll just put in x and see if we get the y value that we've got here, and if we don't, it doesn't lie on the line. Next, we're going to check if this lies on this line, and then after that we're going to prove that the gradient is 1, because we can figure out another point just by looking at this equation. I'll show you what I mean. So if I put in 5 here, I get 5 minus 3. No, 5 minus 2 is. I was putting in the other coordinate as well. Why did I do that? Y equals 3, so that, yes, that does. Because if I put in x equals 5, y is 3. So that point does. Right, now we're going to prove that the gradient here is 1. And we've got one coordinate here which is 5 and 3. The other coordinate, we know that the y-intercept is minus 2. And on the y-intercept we know that x coordinate is 0. So the coordinate of the y-intercept must be 0 minus 2. So now that we've got 2 points here, we can use the formula up here to find out what the gradient is for this line. So I've got my x coordinates here. I'm going to take this to be me x2, y2, and this to be me x1, y1. Just because it seems to work out better. So I'm doing 5 minus 0 on the top. That's actually the x coordinates. Why am I doing them on top? That should be 3 take away minus 2 on the top. That's the y coordinates, and then the x coordinates are here. That's going to be 5 minus 0. Now because we're taking away a minus here, and we're actually adding it. So this is the same as 3 plus 2, which is obviously 5, as we know. Then we've got 5 minus 0, which is 5. And then we know that 5 divided by 5 is 1, so the gradient of this graph actually is minus 1. And just to let you know, because I don't think I actually told you, the gradient is a measure of how steep a graph is. Like, for example, this graph here is not very steep, and then we can get a bit steeper until we've got one of these ones, which is actually classed as an undefined slope because it's just going to infinity. So that's basically what the gradient is. And there's some problems involving graphs with linear expressions, equations. Wherever getting equations from the expressions, doesn't matter, you can call them equations or expressions, you know.